Hi there. In this workshop today, we are going to build a data pipeline for processing 1 billion records. The dataset we are going to work with is general practitioner. It's general practitioner prescribing data. In the UK, every time you go to a doctor's office and you get a prescription, this data is recorded. It's anonymized. We don't know who exactly got the prescription, but this is recorded. So on the entire country level, this data is saved. So as you can imagine, this is a very large data set. And for each month, we know which practice, which doctor office prescribed what kind of chemical. And we have a lot of data, like every month, it's around 10 million records. So we have this data for quite a lot of time. So in total, we are going to process 1 billion records. And as the database, we are going to use Exasol. So Exasol recently released Exasol Personal, which gives you the same powers of Exasol. Exasol is in-memory columnar analytical database engine. It's a data warehouse, and we now can use it for free for personal use. And now in this workshop, I'm going to set up Exasol Personal. Then we are going to ingest the data from this data set into this database. So we're going to do this in two phases. First staging phase and then production phase. So in staging phase, we are going to prepare the data. In the production phase, this is what the analysts are going to use for querying this data set and building dashboards. Then we are going to automate it with Python, and we're going to automate it with Kestra, a workflow agent, a workflow orchestrator, and then finally we will build a dashboard that displays all this data. So that's the plan for this workshop, and I'm going to start with setting up an Exasol cluster. And by the way, everything that we do today is actually available in this repo. So I'm going to include this repo in the link. So here I'm going to follow all the steps. And actually, this was a workshop I delivered in person a few days ago. So on this workshop, it was an in-person workshop. Some things didn't go well, didn't go according to my plan. So that's why I am actually recording this workshop now. My original plan was to just record it on the event and then share it with everyone. So now I'm re-recording it. I'm also going to share it with people who attended this workshop. So you'll have access to this information. So you can, if you want to, redo this workshop afterwards, right? So that's what I wanted to say. And in order to start Exasol Personal, you need two things. You need an AWS account, and you need to have Exasol Launcher. So when it comes to Exasol, when it comes to AWS account, in this repo, we have setup, and we have a local MD file that explains what exactly you need to do. For Exasol, for AWS permissions that you need. So these are the permissions you need to have in order to actually be able to deploy a cluster, Exasol Personal instances, right? So this is what I came up myself. I think there is also a recommended, more minimal, more restricted setup. I think here you can find it in GitHub, so you can go through this and see the official recommendation of what your AWS setup should be. So, and I also downloaded the CLI tool for Exasol, or it's called Exasol Launcher. So I'm on Windows, so that's why I use this Windows launcher. You can select anything else according to whatever operating system you have. And now, so this is the terminal I'm going to use. So if I do Exasol, I already have it. I unpacked it into my bin, so which is where I say Exasol. So it's in my bin directory, and bin is in my path. So that's why when I type Exasol, I can access it. Okay, so first thing I do is I create a folder deployment. And okay, I'm going to delete it then and create a new one. And I'll go there and I do Exasol install AWS. So for that, before I actually do this, it's important that my AWS is configured and I also have default region set. In my case, default region is, I think, let me see, AWS default region US. We can go with the EU central one, whatever, like you can choose the closest one for you. Okay, so let me do Exasol install AWS. And now what is going to happen is we are going to set up an Exasol cluster. So it's going to take some time. So while this is happening, while Exasol cluster is being configured, we can actually take a look at what we have in our deployment folder. So I need to create a new terminal, and I'll open Visual Studio Code there. So this is the deployment, and by the way, notice that I edited it gitignore, so it's in gitignore, the entire thing, but also you can make it more granular, but typically you probably want to put the entire thing in gitignore, right? But the reason you might not want to put the entire thing into gitignore is because actually inside there is infrastructure, so there are some Terraform files, right? So we don't really need to do anything, so the Exasol team is managing all these things, but in case you might need to do some customization, maybe it's a good idea to actually commit these files to Git or whatever, like somehow keep track of what exactly infrastructure-wise is happening there, right? Okay, so this is what we have, and at the end we will also have, okay, we already have secret, so this is our database password, and I think we will have a file called deployment, which will tell us how exactly we connect to this cluster. But it's been created, so that's why I'm going to create now a folder code, and in this folder I'm going to take a look at the data. I already showed you, let me close that. I already showed you this link, right? So this is the page that contains all the like all the files. And we can see that there are quite a few of them. So I'm going to start with, so let's start with address, right? So this is an address. I copy the link. I'll create a folder, data, and I'm going to go to this. Actually, I already have commands that I need to execute here. So it's a bit convenient. I can just copy paste, right, instead of typing this. So we're starting with address. This is exactly the link I took. So these are the names of doctor offices, right? And this is the link, and I'm going to save it as other, so this file, right? So for me, it's a bit more convenient to copy rather than type this whole thing myself. And now I'm going to open this, take a look, and this is how the code looks like. Right, so what we see, it's a CSV file. It has this weird, I don't know, spaces, right? So everything is aligned. And I think the reason for that is just for some systems, it's easier to parse this way. Every row has exact same size in kilobytes. So what they do is they just read it in blocks, right? So they know that if I need to access the row number 15, it's very easy to calculate how you exactly go there, right? So I think for some systems, this is just the way you represent data, but this is a CSV file, and we have so this weird button at the end. We don't have any headers, right? So even though it's a CSV file, it's separated by comma. We don't have headers. And the line ending is this CRLF, which means that at the end we have this /r/n, not not the usual just /n, right? So this would be, I think it's just LF, and this one is CRLF. Okay, so this is our address, CRLF, no header, right? So this is the address. Now let's take a look at the next one. The next one is chemicals. So these are the substances that are prescribed, right? So the first one is the practices, the doctor's offices that prescribe the substances. And the second one is our, how to say, dictionary with the actual substances, the actual chemicals. So let's take a look at them. So this is how they look like. Again, we have a CSV file with, this time we have a header. Then actually we have also a period, but period is for some reason in the header. and then this one is empty, and this is how it looks like. Yeah, so it's also kind of strange somewhat, but yeah, so this is how it looks like. And yeah, it's again the same, and offline sequence is the same. So for chemicals, we have CRLF and header. And then finally, we have the last one, which is here, prescriptions. And this is a very large file. I don't want to download it. It's over 1 gigabyte. So what I want to do is I want to just download the first 10 kilobytes of this file. And I do that using curl. So -R with curl downloads the first 10 kilobytes. All right, so I'm just going to execute that. And this is how it looks like, right? Again, header, some padding, period is actually included. Yeah, and again, it's CRLF. Okay, so it's prescriptions, CRLF, and header, right? So what we see is they're quite similar, all use CRLF. Two of them have header, one doesn't have header, right? So let me actually see if this is finished. Okay, so we need to wait a little bit. So what I'll do now is I'll put it on hold. So I'll just pause it, and we will wait till everything finishes, and I'll be back when it finishes. But actually, maybe before, while you're waiting, I'll say what we are going to do next. So next, we are going to use this database to actually start processing the data. We will upload this data to, so let me add a plan. Okay, plan is first upload to staging area. In the staging area, we will first process raw CSV, then we will transform it to the form we need. Then we will upload transform to production. So this is what will be used by analysts. So first we will just use plain SQL. Then we will use Python, and then we'll orchestrate with Kestra. And then finally we will build a dashboard. So that's the plan for the workshop. And for plain SQL, I want to use DBeaver, which is a tool for SQL, right? If you don't have it, you can install it. DBeaver, it's open source, it's free, so then you can download it from here. Works for any operational system. So you download it, and then this page here describes everything, by the way, is included in the repo. This page describes how exactly we connect with DBeaver, how we connect to Exasol. And now let's see. Yeah, while I was talking, it actually finished, so I don't need to now put it on hold, because I thought, okay, maybe I just need to wait a little. Okay, so actually we already see what we need, right? So these are, let me copy it. And for the password, so we have this deployment. I promised you that it will appear. So what we have is URL. This is where the database is deployed. And we have some other things, but this is the important one, right? So the name. And then another thing is we have secrets. Okay, of course, here I'm sharing the secrets with you because I'm going to destroy the database after we finish, but potentially, like, this is not something you want to share, right? So you don't want to expose these things. So I'll put it, okay, let me save it. I'll put it here. And now I'm going to open DBeaver. DBeaver. I thought I already had it open. And then I'm just going to type in these things there. It takes some time, so I'll be right back when it loads. Okay, it took maybe 30 seconds. So now I go to database, new database connection. I go to analytics. Actually, the instructions, if you're interested are here. So they exactly say how you use it with DBeaver. Exasol. And then now you need to define what is the host list. Actually, so when you define the host list, you see they recommend to also include this thing, which is a TSL encryption certificate. This is important, otherwise it will not connect. Right. So the line I need to do is this first host, and then this certificate fingerprint. Okay. Port is the same. Username, I think it's sys. Yeah, and password is this one. Okay. Finish. So here right now, it would ask you, do you want to download a JDBC driver for Exasol? I have already done this, that's why it doesn't ask me, but for you, it will prompt you to, it will ask you, do you want to download JDBC driver? You say yes. And now I do SQL editor, open SQL script. And I test it, select one, like that. And I just run Control Enter. And then I see one being returned. Yes, hello. Okay, so it works. Can I make it larger? No. Yeah, it's a bit, I wish I could make it larger. Maybe there is a way, but maybe it's less important. Okay, so we have this. Now in the tutorial, actually, I was going to show you how to get this same connection information from using Python. But since we already got it, I'm going to skip it. We'll have to come back to this later. So I will just take a note of these things right now. And we will come back to this later. Okay, so we set up DBeaver, and now we are going to load data with SQL. So I'm going to create two schemas. And as I already told you, we want to create a staging area. This is where the raw data and process data are going to be stored. And then we are also going to create the final table, the table or the schema, the tables in which are going to be used by analysts. Right, so I'm going to execute that. Okay, maybe I should separate them. Okay, now this one, and now I'm going to open this one so that I don't need to write like which schema I use. It's always the same schema. Okay. So now when I do create table, this one, I am going to use this schema. Okay, so the first thing we are doing is we are loading the address data to Exasol, and this is how it looks like. So we have period for which the data is, practice code, practice name, address 123, county, postcode, extra padding. So this is an exact one-to-one mapping with the actual data, right? So this is period, code, name. What else do we have? Practice name, right? Address 123, 123, then county, postcode, and extra padding. Right? So I am going to create this table. Control Enter. Yeah. So this is how I execute it. With Control Enter, with on Mac it's probably the other thing you have instead of Control, right? Okay, so I created the table, and now I'm going to load the data from the CSV file to that table. So I can do this using the import statement. Right? I import into this table. From this address, this file, column separator is comma, because this is this is a comma CSV. Row separator, remember, it's all the same for all the files. Skip 0 rows, there is no header. That's why we want to load the entire CSV file, and encoding is UTF-8. So let me execute that. Okay, and now when I do select, I think I already have this query here. So we see that this is the amount of rows that we have here. So this is the amount of rows we processed, we ingested, right? And now we need to process it a little, because if I look at the data, we can see that it has, well, this doesn't, but we have this padding, right? So we want to remove this padding. Here, this padding is everywhere. Other than that, I don't think we need to do much more at this point. So I just want to remove padding. And for that, I'll create a new table. And then I will load this data from this raw table. So this is a raw table. This is exactly one-to-one mapping with the CSV file. And now from this raw data, I want to create a table that is just already processed, trimmed, right? So this is very simple processing. I'm just going to trim the data, right? And I'm going to insert it back, right? Insert it back into this new table. So here I hardcode the period, I trim the rest, and that's what I do. So there is nothing else happening here. And now if I check it, so I need to, oops, did I replace it? Ah, yeah, from, sorry. It should be without a row. Okay, so now it is trimmed, right? And this, so when we trim an empty string, it becomes null, right? And we don't have this weird padding at the end, right? At this point, we don't need the row table, right? So we are going to drop it. Why keep it duplicated? Yeah, so let's drop it. And now one last thing. So here we will do the same procedure for all the tables. So we'll do this for chemicals. We will do this for prescriptions. But here with addresses, there is one thing that is important for us. So I want to show you again. So we have this address 1, address 2, address 3, which is that could be confusing, right? And sometimes we have like, can I do larger limit? Sometimes it could be empty here, right? So what I want to do now is I just want to turn it into a proper address, right? So I want to just have one column call address, and that's it. I don't want to have anything else, right? It will simplify things for us because like this is really difficult to query, understand, and so on, right? And for that, I'm going to create this processed table. So this is going to be the final staging table that we are going to use before we put this data into our production database. Right, so let me now do this. So now what I'm doing here, I'm inserting into this new table. I'm inserting the same data except for addresses. I process them. So what I do here, I concatenate all these 3 addresses, right? But sometimes they are null. So if this one is empty, right, it means that we will have two commas in a row, which doesn't look very beautiful. That's why we have replace. So if we have 2 commas in a row, they replace with single comma. And also at the end we trim. So if something starts with a comma or ends with a comma, we also remove it, right? So then it looks more beautiful. Okay, now this is executed. And now if I do select, from this limit 10, or let's go with 15. So we see that this is how our address looks like now. Right? So this is much more pleasant to deal with. Okay, and I think that's it for the address, right? So the next thing, yeah, so this is just a summary of what we did. So the next thing I want to do, keep it. Then we have code, and we have name, and we have period, right? So that's what we have here. So now this is exactly the same, except we skip one single row. Right? Skip one. The rest is the same, of course, table. And we can see what we have in this chemicals, right? So this is substance code, the name, and period, right? So this is how our data looks like. So here we don't need to do anything else, right? So it's already quite processed. So, and then finally our biggest table. This is called PDPI, which is actually, it's a complicated name, but it is prescriptions, right? For this period. Again, it's raw. We have a header there. That's why I will skip one. And it's going to take a bit of time, right? Because this is a very large data set. It's over 1 gigabyte. It has 10 million records. So Exasol now needs to download this, parse it, and insert it inside a table. So let's see how much time it takes. Shouldn't be like too much. It downloaded 1 gigabyte file, it parsed it, and it inserted into this table. We still need to trim it, right? The same process as before. So we see that it has almost 10 million rows. And this is how the data looks like. So where we can see, yeah, here we need trimming. Extra padding, we don't need it. So this one is already parsed as decimals. That's good. So this is integer. This is integer. Yeah, we don't need to do much. We just need to trim, and that should be it, right? Okay. So that's our table, the final table. And I'm going to insert trimmed data. Okay. So this one should be faster because we don't need to download the dataset. We only need to move and process them, the rows, right? So that's why it's much faster. And then finally, I'm dropping the raw one. Yes, I want to execute that. And let's see how the final result looks like. So it's the same, except we don't have like this padding. This is, yeah, this is trimmed. Yeah, so this is how our data looks like. So now with that, we completed the first part. Here, so we did this uploading to stable. But we have the second one, the second part, transforming it to production. For production, so these names, when you look at them, they are a bit cryptic. Well, a bit maybe is understatement, because what is BNF code? What is BNF name? What is NIC? What is actual cost? Like, you really have to know these abbreviations. So we want to make these things more understandable for analysts. So we want to change how the data looks like. So in our final table that we're going to use for analysis, we are going to have more understandable names. Then also for this one, SHA, PCT, it's codes, right? But we don't really know what they are for because we don't have any. So they are codes, they are IDs for something, but there are no tables that we can link them to, right? So in our case, they're kind of useless. So in the final result, we can just drop them. We don't have to use them. So that's what we are going to do. So where is this thing, right? So we are going to process it. And yeah, I think now this is where we're going to load this to a data warehouse. So we're going to have more logical names like chemical code, drug name, net cost, actual cost, things like that, right? So this is more logical names. For practice and chemical, we don't really need to do much processing. We already processed this for address, right? So we just use it as is. But now, because we have data that we have for individual months, where's my DBeaver, right? So this is for this specific month, right? And we are going to have a separate table and staging area for all these months. What I want to do now is I don't want to have a table that is specific for this month. I just want to have a table that the analysts are going to use, and they don't really care for which month it is because they always can filter on the period to understand what they need, right? So I'm going to insert data into our warehouse without this, right? But we still want to keep the period. And let's start with processing, yeah, addresses. right? So we will actually call them not addr, addr, but we are going to call them practice because this is a more logical name, right? So we will call them, we will have these columns: practice code, practice name, address, county, postcode, period, right? And since this is going to be our final table, sometimes what can happen is the practice can change their address. It doesn't happen often, but it can, right? So what we want to do now, when we insert into this table, we want to see, okay, if the data we're inserting is more fresh than what we already have in this data, we want to replace the data, right? So if there is a new information about this, we're going to replace it. If there is an old information, or if there is already information about this, old information, we're going to replace it. If there is no information, we are just going to insert it, right? So this we can do with the merge statement, right? So this is, it's kind of complicated query now. So I'm going to put this together so it's not confusing for DBeaver. So what we do is we merge into practice target. We call this table target using, so like from this table, we map it, we look at the key to understand if something is already there or not there, right? And if something is there, what we do is, if this is a more recent record, if it's an update of what we already have, we simply overwrite it. So maybe they changed the name. So if now period is 2011 and 2011 January, and what we have in the target is 2010 December, right? And then if this is the case, then we set practice name to whatever was there, like coming from source. Otherwise, we keep the target, right? And we do this for all the things, right? And if something, when we don't see data, like this is the first time we see this doctor's office, then we simply insert it, right? So this is what this complicated query is doing. It looks complicated, but it's actually not that complicated. And besides, you can always use AI to write these kind of queries. This is right, and this is the code we came up with. It's complicated, but later when we insert this into Python, when we go from using plain SQL in DBeaver to creating Python scripts, we will simplify it. Okay, so now did I already execute it? So this is the final result, right? So this is the our production table, right? So this is what the analysts are going to use, and they will join the prescriptions table with the practice table using this practice code. Okay, next one is chemicals. So chemicals is similar, right? Except we say chemical code and chemical name instead of what did we have there? Chem sub name, right? So it's more again logical. So this is exactly the same logic, right? Chemical names are very, very unlikely to change. So in practice, we don't actually, in the data, I later checked when I uploaded all the data, there were one of few cases when the practice actually moved, right? Still very rare, but it happened. Here, it never changed. Like chemical is always the same, right? Okay, so now we did this, and this is our final table for chemicals. And yeah, let's see the results. So this is how it looks like: chemical code, chemical name, period. Cool. And finally, prescription data. So this is how it's going to look like. We already talked about that we are going to give it more logical names. BNF code, I'm not super happy about this name, but like there was no better name because we already have chemical code, and chemical code is a subset, like the prefix of this one, right? So this is what we are going to use to merge with this one, right? And the rest of the code encodes some other things like quantity, packing, and stuff. Like so, probably we can actually encode it properly in the table, right? In the final table that analysts are going to use. So for them, it's actually easier to access this information, decode it. I don't know much about these things, so yeah, this is something we just need to keep in mind, right? So for the final table, for the production table, it should be very, very humanly understandable. So we need to translate raw data to something that the analysts in our company can understand. Okay, I already created it. So now what I want to do here is we are inserting into the prescription table. And let's say we run a job and it fails midway. So we want to continue, we insert again. It means that we already have 5 million records from the previous attempt and 10 million records from the new attempt, which is 15 million records, and we have duplicates. Or maybe we change something in our code that is processing this, right? So then we insert it again, we will have duplicates again. So that's why before we actually insert anything, we delete any existing rows for this period and we insert again. So this is the concept is called idempotency. So every time we run a job, it does not produce duplicates, right? So it behaves in exactly the same way. So that's why for that, we want to delete everything for this specific period, of course, right? We don't delete everything from we don't drop the database. We just delete everything for this period that we are inserting. So while previously we were merging, right? So we were checking, okay, do we already have this data? If yes, let's update. So this way we made sure that there are no duplicates. Here for the duplication is different. So we just drop all the records from this period and insert them again, right? Because here, if you know what it means, so this is dimensions. So we have facts and dimensions in data warehouse design, facts and dimensions. Facts are actual things that happen in the past, so a transaction. So a doctor has prescribed a substance, a chemical to a patient, right? So this is a fact, this is a transaction. A dimension is like these are the parties involved, like doctors, chemicals, not parties, but like things that these facts are talking about, right? So what exactly was there that happened, right? So these are description tables, and this is more like transaction tables, right? So in our case, doctor practices and chemicals is dimensions, and facts is our prescriptions. And by the way, we also call it prescriptions, not PDPI, because I have no idea what it stands for. Okay, so we delete it. The next thing we do is we insert the data. I think I already mentioned that this drag code is a substring from like first 9 characters, because this is exactly what we are going to use to merge with the chemicals table. The rest we don't really change much. Okay, so let's see what we have there. So, well, here it's the same as just new names, right? And only one table. Yeah. So I think that's actually it. So we were able to ingest all the data into the staging area. And then from the staging area, now we have the actual tables that are going to be used for the analysts. So let's see how many records we have. Okay. So this is all good, but of course, this is not something we are going to do manually. We're not going to copy paste SQL code into our DBeaver and then change this, right? So change this name, change this name. We want to automate this. And I'm going to do this with Python. So now here, this is what I kept for later use. I will not save it. So I'm going to do it with Python. We already have the code directory. I think it's here, right? So the code directory. I also want to close DBeaver. Can I actually close the connection here? Disconnect. Because in case of Exasol, in case of Exasol Personal, we have only 5 connections. So there is a limit for the personal license of 5 connections. Exasol told me that they are going to increase it. So we will see this. I don't know how official this information or not. Maybe they will increase it, maybe not. But now the limit is 5 connections, right? And we need to be aware of that. That's why I closed the connection in DBeaver, because now we're going to process data with Python. And at some point, I want to multi-process data, meaning like I want to ingest data in multiple threads so we can do it faster. So that's why I close the connections. It's important in this case because we don't have a lot of connections. I need to be aware and close it. Okay. So now I'm in the code directory. We don't have anything except data here. So now I'm going to create a UV project here. And I'm going to add libraries that we are going to use. So the first library is requests, then Beautiful Soup 4 and PyExasol. Requests, I need requests to be able to send requests to this page. I send a GET request and I get source code. So the source code looks like that. And then we have the actual URLs that look like this, right? So this is an A tag with href attribute, and this is the link. So I want to write a script that is getting this page, and based on that gives us a list of all the CSV files, right? So this will make our life easier, right? So we will not need to copy paste things from this file, right? And Beautiful Soup is a library for parsing HTML. So it can actually, we are going to use it to find all A tags with href attributes that end with CSV extension. Right? And then finally, we have PyExasol. This is the connector that allows us, a Python library that allows us to connect to Exasol from Python. Okay, so this is the setup. And so what I wanted to do already before is I wanted to create this utils folder. So utils folder is going to contain the useful utilities. So it's going to be a Python package. That's why Python module. That's why in utils I have this init method. So I can do utils.connectioninfo to import utils.connectioninfo to actually access this script, right? And then this is connection info. And what this connection info script is doing, it's going to this deployment folder. It looks for deployment, it looks for secrets, and it displays this information, or we can use this script, we can use this module to actually connect to Exasol, right? And we are connecting to Exasol in the next script, which I will find now. Yeah, the next two scripts, the next two files are doing that. So I will start with, let's take a look at this, right? So we took a look at this already. So it returns host, port, user, password, deployment ID. Not sure why we need it. And also fingerprints. Remember, when we were configuring our DBeaver, we needed to add this long string. So this is the fingerprint. So it's important for security. So the script also gives us the fingerprint. And then this script, no, go away. So this script, connection info, this module is used in the DB module. DB modules is used for connecting to Exasol. So when we invoke connect, we get the connection. So we use this config from connection info to actually connect to Exasol, right? And then there are some helper methods like, okay, this is a function for importing CSV. So it's doing, I already showed it, I already closed it, but what it's doing is inserting, it's parsing, it's loading CSV file to the database, right? So this is exactly what it's doing. So it's building the query, like a drop table, create table, and then we execute that statement, and then we check that it was actually loaded, right? And then the final thing is we need to put this thing here, like what is the row separator, how many rows we need to skip. So then I have this helper function that is letting us understand how the data looks like. So it detects the format. The thing is with this data set, sometimes even though we looked at this particular month, it doesn't mean that all months are the same. I think there are some inconsistencies. I remember for some months, they use, for example, usual /n ending. Yeah, sometimes there is one less column than in other cases. So this one here, that's why we want to count the number of columns. We want to know if there's a header or not. We want to know what is the row separator, meaning line ending. And we do this by downloading first 4 kilobytes of the file. figuring out what is the format, and then we use this function to actually, where is it? It's DB, to actually load this, right? So this is the code we have. And now, if I do this, wait, do I have this thing here? Yeah. So I just wanted to show you UV run Python -m utils connection info. So when I do this, these connection details get printed, so it accesses them from deployment, right? But then, again, then you can use it for connecting to DBeaver or whatever. Like if this thing is not accessible for you anymore, right? Okay, and then of course, like all the code that we are going to write now, going to create, they are going to use this connection info too. Okay, so let's do this. So first, we scrape the data. We scrape the data, and this is what this find URL is doing. We scrape URLs, right? So we send the request to this dataset URL. Then we go through all the A tags. We get the href attribute, and then we check if this is actually the attribute we need, right? And then maybe it's better if I just execute it so we can see what the result looks like. So now we have in data, we have this JSON file. This is how it looks like. So we were able to find 101 month. And for each period, for each month, we have addresses, we have chemicals, and we have prescriptions, right? So this is what we have right now. Right, so this is what the first script is doing. This were find URLs. And now we want to ingest addresses, we want to ingest chemicals, we want to ingest prescriptions, and we want to use Python scripts for that. Okay, so let's start with the first one, load address. So what load address is doing is exactly the same thing we did before, right? So it loads raw data. So it uses this detect CSV format function just to make sure that we are properly parsing it. Then it creates this table name, then it imports CSV. So it loads the raw data, then it trims the data, right? So it creates a table, right? It trims the table. And then for this particular case, we have one extra step, right? Where we combine the address, right? And then finally we merge it into the warehouse. And here I have this helper function, newer, right? So practice name is whatever is newer, which is this thing, right? So it just makes it a little more compact. Okay. So, and this is what we do. So we load row, we trim, we combine, and we merge it into the data warehouse. Right? So now when I run it, so this is how I run it, we get data for 2010 April, August. Okay, now let's do the same with chemicals. So let's actually take a look at this. So it's even simpler, right? Because there are only two steps. The reason we have this get row schema, and also here, sometimes these tables don't have extra padding, right? So this is why we are doing this. Okay, so load row, the same, trimming, same as we did before. It's just here we put the exact period for which we are doing, and then merging is exactly the same, and loading is doing both. All right, so now when I do this, the Python file, raw data, loading raw data, trimming data, and inserting into the warehouse, right? So first delete, then insert, and then we just count how many of them are there, right? So trim, insert, yeah, load, trim, insert, 3 steps again. And this is exactly the same code as we saw before. And I don't go into details of what exactly, like how exactly to write this code, because it's boilerplate code at the end. And like I also asked Claude Code to write this code. So this is, of course, I cleaned it. I wanted it to look understandable, but at the end, like I don't really see a lot of value explaining what exactly is happening there. I think it's more or less self-explanatory if I knew what's happening, or like whatever AI you use. Okay, so this is done. So we have our Python scripts, and we can load our addresses, our chemicals, our prescriptions. Everything is first computed in staging, then in production. In reality, probably would have separate scripts for ingesting into staging, and then another script that would ingest in production, or final schemas, let's say, periods, and manually change them. I want to execute it for everything. And for that, I want to use Kestra. Kestra is a workflow orchestrator. So it will let us not only have like a good interface where we can see what exactly is happening, we can easily trigger these jobs, but also in case something I had a small break, and then after this break, I started recording the rest of the session, and I found out that we use Python 3.14. For some reasons, when I did UV init, by default it used this one, and within Kestra it wasn't working. So I'm going to save some time. So I'm going to show you how do we roll back to 3.13, right? And then we use it in Kestra, inside Kestra, right? So I replaced this .python version, and I replaced my project toml with 3.13. Then now the next thing I'm going to do is, let me reset this. I'm going to remove our venv. And then also I want to create, there are many commands I executed, so I want to create a virtual environment with this command uv-venv minus Python 3.13. So here I want to force UV to use Python 3.13. And now I do UV sync to install all the libraries. UV sync. Okay, so now we actually, if I do UV run Python -c, it's 3.13, not 3.14. And I want to check this with this thing. So actually, this is something I forgot too, is I want to run the check. So this is a file that we can execute. So it is here. So what it's doing, it's showing top 10 chemicals by count and top 10 practices by prescription volume. So it's doing not a super trivial query. So it's group bind, and then we join this group by. Check. So as you can see, it's quite fast. It's only 10 million records, but still it's quite fast. Okay, so now I want to do Kestra. So I already created a folder, Kestra. Oh, did I not? So yeah, here we have this, the directory Kestra. And I want to download, so I want to create also inside Kestra, I want to create folder flows. So this is where we're going to put our Kestra flows and the definitions of our flows there. And then I want to download the Docker Compose file for Kestra. So this is how it looks like. So here we have Postgres. This is what Kestra is using for storing data internally. So it's Kestra Postgres. And now let me do Docker Compose up. For me, it's going to be quite fast because I already ran it like 20 minutes ago. So now it's running, and I go to localhost 8080. I guess it's still being loaded. Yeah. Yeah, maybe it will work now. Okay, so for me, it just loaded without anything again, because I already did this a while ago. For you, it will ask you for password. So the password is going to be this admin Kestra.io password. So this is the username and this is the password, right? So you'll be prompted to enter username and password, and this is what you put. So this is defined in Docker Compose. Okay, so now I go to, so now let's create our first flow. So this is how our first flow will look like. So I'm going to create a file inside these flows, and this is going to be the content of the file, right? So it's going to just print hello world from Kestra. I go to, maybe I update and then I see flows. Yeah. No flows yet. Okay. There should be a flow. I just placed one. Okay. Maybe I'll just create one. Okay. I save. hello world. I'm wondering why my flow does not appear. Should I click refresh data? Yeah, I don't know. So I hope it will actually work, because otherwise I'll have to stop it again and figure out what's the problem. Okay, so the next thing I want to do is I want to actually extend it. So I want to add more things. So I'm going to go to this flow that we just created. I'm going to edit flow, and I select everything and overwrite. Okay, yes, there are some read-only properties. What I want to do now, I want to install dependencies, and then the second thing I want to run is find URLs, right? So first is UV-sync. Second one is scrape that page and get all the URLs and save them inside a CSV file or JSON file. Let's execute that. Okay, so it's installing dependencies, it's doing UV-sync. Okay, this is fine. And now, so of course, could be a new thing for you. We use Kestra in our data engineering course. So if you don't know our data engineering, check the course. Okay, so here I can see that our flow works. So we actually can load address. Yeah, where it is. Yeah, so we loaded this address. And this is how you build flows. Now I actually want to load more data. So this is the things I want to load. So I need to go to code, and I think I need prefix, right? Because then I run Docker Compose up. So now I need to do this prefix, and then so now I have this. Actually, I can see that this is what we created in Kestra, but it just didn't appear here. Okay, I'm hoping now that this data. Yeah, let me just restart it. So what I'll do is I'll just do Control C here. It's going to stop, and I'm going to do Docker Compose up again. Interesting that I can see it here, like it was saved, but it didn't appear in Kestra. Although, like it actually, I configured this thing, so it's watching this. So every time I put a new file, it's actually supposed to automatically pick it up. Okay, so let me put it on hold and wait till it boots. Okay, so it started. So I can see that actually it sees the flows. That's cool. So I hope now when I reload it, it works. Cool. And we see this hello world too. Anyways, I want to let's leave hello world. We're already going to edit this, and this is what is inside. So we load raw data, right? So here in this thing, in this UV run, we can actually specify that, not only specify the period, but also the step, right? So if we don't specify the step, it runs all the steps, but if we specify the step, it runs only that step. So first we load raw. This is the first step. Then the step is streaming. Then the step is combining. So putting this, no, this is still staging. We combine an address, and then finally merging this to the data warehouse, right? And then we can also parameterize it. So here we have inputs, which is period, which is string, right? And then we use this kind of templating here to say that, yeah, actually same, right? So there is not much difference, right? So we load raw data, we trim data, we merge data. Well, we don't have this extra step of combining addresses. And then again, it's parameterized with a period, right? So now when I execute it, it's 2011, right? So then it should be pretty fast, right? Because this is also a small data set. finally, we have prescriptions. Same thing. It's just more data, right? So we need to load more data. Load row, trim, and this step is called insert, not merge, because the way we add this to the data warehouse is different. So let's also do this for this. So this is going to be a bit. This is going to take a bit longer, right? To remember, for 2010 August, it took 21 seconds, 22. So I expect similar. That it would take similar amount of time, right? And then first it loads row. Should be about to finish, I guess. Yeah. Now it's streaming. It takes less time, and then final merge is also less time. But yeah, of course, these things take still some time because we are moving data from one table to another. And we can have like a super flow, or what's the name? Well, another flow that contains these flows, right? So what this flow is doing is it says, hey, first I want to execute a subflow with name load address. Then I want to execute a subflow with name chem, and then I want to execute a subflow with name PDPI, right? And here we will have the same sequence as before, except like each step here in the sequence is a flow itself, right? Then we also say that here, yeah, we have inputs, right? So again, the same thing. Then we just pass this input to the subflow. And we also, if something fails, we can retry. We can say, hey, like if right? And then allow failure means if we fail, we continue with the next one. The reason I configured it this way is because one of the, I think, addresses for one of the months actually doesn't exist. So the URL is broken. So it will attempt to load it multiple times, and then it will give up, and then it will continue with the next one. Okay, so let me execute that. Loading takes surprisingly long time. And then we are loading the chemicals, and then finally the prescriptions. I wonder why it takes so long. Well, it's not the easiest file to parse, I guess. Yeah, maybe also like it just had to wait for the network connection. Where is it? I'll just do ev run python check.py. So now we have 30 million, right? Because we did it for 2010 August, 2011 August, and 2011 September, right? Okay, so that's why we have data for 3 months. It's 30 million rows. Okay, so now what we can do is we can just load the entire data set, like everything we have. Let's load that. Yeah, I have somewhere another flow for that. So the flow is called load all. And again, we run find URLs to actually find the URLs, right? And then we say whatever periods you find in this JSON file, let's treat this as input, right? So this is going to be our input. And then we do a for each loop over all the periods. And then we execute the subflow, which is our load month, this one, load month, which in turn runs this subflow, and that subflow. So what we effectively have is it's also a concurrency limit. It means that we are going to run it with with parallelization, with degree of parallelization 4. So I hope I closed all the connections, because if I did not, then these jobs might be failing, and yeah, I don't really want them to fail. So let's run it. So I'll go to Kestra. I go to our flows. We should have like it worked. Maybe it's because I have a new computer and I didn't configure something correctly. Yeah, let me quickly restart it. When I restarted, the file actually appeared, but yeah, there is actually a problem on Windows that I discovered right now because of that, and I thought maybe I should share it with you because maybe you're also running on Windows and could be interesting for you. So the problem is the way this thing works. Let me open our Docker Compose. The way this works is it monitors, it looks for events from the file system. So every time I create a file here or update a file, there is a file system is creating an event. And typically on Linux, it works fine. On macOS, which is originally Unix-based, also works fine. But on Windows, when you run it with Docker, the events that here in Windows that happen in Windows, they do not propagate to Docker through this volume mapping. And that's why when we put something here, it doesn't really work. So that's why for Windows, the best way would be to remove this thing. And also this thing is actually causing some other problems. But at least on Windows, but also perhaps the issue I had on the workshop day when these things weren't working were related, right? From what I discovered, this is a bit of problematic thing, and it's actually better to manually synchronize these flows with Kestra, right? By manually, I mean, of course, there is a script that we can use. So I'm going to download this script right now. Do I have prefix? Prefix. And what the script is doing, it's looking at the flows here. It looks at the state of Kestra, and if it sees that there is a mismatch, it actually fixes it. Like, for example, right now, I want to load this. We already loaded. I want to load it one more time. So this script, this flow, sorry, where is it? No, I think I actually wanted to do this. So yeah, so it should, yeah, here you go. So this script, so it finds URLs, then outputs all the periods into a special internal variable, and then does a for each of the periods with concurrency of 4, so with 4 things in parallel, right? So we have this. As we discovered last time, it does not automatically appear, especially now when I remove this thing here. I don't remember actually if I did Docker Compose down. So let me quickly stop and start it. Up. Oh, well, there was no reason to do down because I just did Control C. So it now I mean right now actually it will pick it up because I restarted it, but I want to show you how we use the script. Right, so we do uv run. I need to do it from Kestra. Uv run Python scripts sync flow. Did it start? Yeah, let me wait till it starts. Okay, it starts. Actually, interestingly, it doesn't automatically load. Maybe because I removed that thing, right? So anyways, let me now synchronize flows. And now we see that it automatically, it saw that, okay, this thing is missing. It created it. So now what I can do is I can trigger it. Okay, and now I can see edit flow. So this is my flow, and I can execute it. So now we are executing. The first thing is it's doing is finding the URLs. Well, we know this already. Then after that, it will create. It's taking some time though. Not sure why. And now, yeah, we started months. So this one is the for each thing, load each, right? So this is what it's doing for each loop. And then we have these individual months. So now each individual month will take, loading will take more than last time. How much we had? Like 30 seconds, right? So 20 for loading, like 6 or 8 for trimming, and then approximately the same amount for inserting to the data warehouse. Right now it's going to take more because we are running in parallel. So you see, oh, it's already been like 30 seconds. It is still inserting data. No, it's not a problem. Yeah, maybe actually here we could have done just the degree of parallelism, just 2 would have been enough. Yeah, this is something I can experiment with. And actually 2 is a good idea because, again, remember we have only the number of connections. The limit is only 5 connections per instance. So yeah, if we accidentally send one more request right now, we can actually get some yeah, bad results. Bad results, I mean like a job would break and then it would need to retry it. So not something we want to do. While it's loading, what I want to do now is I want to download dashboard. So this is the dashboard that will show. I don't need prefix, but so this is the dashboard that will show the data. I don't want to run it right now because I'm a bit afraid that if I do this, I will accidentally increase the limit to more than 5, even though it's running in like 4. My initial idea was that I would do this. Yeah, I would do this 4, and then I would run dashboard in parallel. But I know that now after doing the workshop live and rehearsing a few times, I know that it can be a bit fragile, so don't want to risk it. So I'll just wait till everything is ready, and then I will execute the dashboard. But for now, we can also install all the dependencies. Right? Okay. For me, I think I already had them, but for you, it would take some time. Well, not some time, like a few seconds, right? You will see that they are being installed. And the dashboard is implemented with Streamlit. We can check the code for the dashboard. So we have this file check.py, which is checking like top 10 chemicals and top 10 practices, right? And what the dashboard doing is exactly the same thing, right? So it's running the same queries, but also in addition to that, it displays them. So we will see this dashboard in action. Not right now. I don't want, as I said, I don't want to risk it. Yeah. Okay. So now let's wait till it finishes. It should take approximately 30 to 40 minutes. So after that, yeah, we'll take a look at the dashboard. So see you soon. So while it's processing, we see that one of them is orange, right? And this is a warning. And we can see what it is, like why it's there. It's actually not a problem. But let's see. So subflow execution for flow ends in warning state. So let's see what is there. So we can go again here to Gantt to see what is up, what is happening. So these two are green and this one is orange. So we click there, again there, and here execution failed, last error, command failed with exit code 1. So we can see in logs that yeah, it tried doing something. So let's see where the problem is. Well, basically, I know the problem. So from here, from logs, I cannot really tell it, but problem is that the file here named resolution error. So this file doesn't work. It doesn't exist. You cannot really process it. So it's just for one of the files that we have on one of the files here. It doesn't exist, right? And this is addresses. So in our case, since it's addresses, it's a dimension, not a fact. It's fine, right? So it's unlikely that only during this month there was an address that there was a doctor's office that did not exist in any other months. So for us, it's fine that yeah, there is a problem. Okay, and then for the rest, I'll let it finish and then we'll discuss the results at the end and also look at the dashboard. Okay, so it finished. The state is warning because one of the things here had a warning, right? We already discussed it. So the whole thing took, what, 33 minutes? But I think, yeah, maybe if we were running in 2 threads, it wouldn't be, yeah, that different. But this is something we can experiment later. Okay. So now, what we can do is, how about we run check again? So this is, yeah, we have 1 billion rows. Okay, now it's not as fast as before. I should have added a timer here. Yeah, it's taking some time. Okay, while it's calculating, I'll create a new terminal. And it actually should be faster. But okay, like we're doing it in 1 billion, that's why it's not super fast. So what I want to do is I want to start our dashboard. So I'll do uv run Python. No, it's streamlit run dashboard.py. So yeah, this is taking some time. Okay, so top 10 chemicals. Flutu Casone. I have no idea what is that. Enteral. Maybe it's good that I don't know what these things are, right? Okay, this makes sense that it's quite commonly prescribed because maybe for people with diabetes, they need to do it very often, right? Okay. So this is the most the practice that issued most of the prescriptions. Okay. Well, I have no idea where it is. I guess London. Does L mean London? Yeah, don't know. Anyways, let's start this thing. So now these queries are cached. What? This was new. This thing was new. I have not seen this before. So these queries are cached. That's why it's super fast, right? So, and now we can actually see these things. It's automatically refreshing, and my idea was to actually show when, as the data is loading, how this thing is changing, right? Yeah. Well, I was kind of a bit afraid to show you this because, as I said, we have this connection limitation. But here we go. This is what I wanted to show you. Well, actually, that's it. The only thing we need to do now is stop the cluster. So, and for that, I will go here. Well, of course, we can do Docker compose down here, or I'll just Control-C to stop Kestra. And when I go to deployment, I can do Exasol stop. I'm not going to do this because I want to do a few other things after we finish, but it's important to stop. Otherwise, you'll get a bill at the end, right? And this costs 25 cents per day. Well, per day, oh, I wish per hour. So per day it could be like times 24, right? I mean, you still don't want to pay for something you don't use, right? And then when you want to completely remove it, you do Exasol destroy, right? So it completely wipes the entire cluster from the face of the planet. You'll never, of course, it deletes all the data, so you will not be able to recover it. Okay, and when you do Exasol stop and Exasol start, it says that IP will change, but because in our scripts, where is it? Because in our scripts, we use this connection info, it will automatically get a new IP. So we shouldn't worry about this. Okay, that's it for the workshop. I hope you like it. So yeah, all the materials are going to be here in this folder, in this repo. I will adjust a few things to make it similar to what we did before, or what we did together. So then, like maybe move some things around. So it's similar to what we did here. Okay, that's it for now, and see you later.